so lucky to have the Occoquan Reservoir as a resource. I mean, there's nothing more central to the longevity of our community than clean drinking water. But if we're not careful and intentional about our planning, we could lose it. It's not a guarantee that we'll have it forever. It's something that we have to fight for.
The trend, especially in the chemical data recently, we have been seeing a huge amount of conductivity readings, and probably attributed, not probably, but attributed to de-icing of our roads during winter. And this has a huge impact on the aquatic lives.
Nestled in the suburbs of the D.C. metropolitan area in northern Virginia, the Occoquan Reservoir supplies drinking water to nearly 1 million residents. Managing it over the long term means balancing land use, stormwater control, and wastewater treatment. 50 years ago, water quality issues led to groundbreaking policies, making the reservoir a model for drinking water management. But today, population growth is causing new water quality challenges. Providing clean, reliable, and affordable water in a growing region, especially with droughts and stronger storms in the mix, is no small challenge. Fortunately, this area has a history of tackling big issues head-on. When the Occoquan policy was adopted, it created the Occoquan Monitoring Lab through a partnership with Virginia Tech, the Virginia Department of Environmental Quality, Fairfax Water, and other local agencies and governments. For 50 years, the lab has been consistently tracking water quality in the reservoir and its tributaries. Having this historical data helps shape smart policies to meet today's challenges and ensure safe water for future generations.
What we thought was that maybe we could leverage all of this emerging technology, machine learning, stochastic simulations, cutting edge physics, and see if we can put all of that together, package it into a web app that anyone could jump on and use. So rather than waiting a year for an answer, maybe spending a lot of money getting there, you could just simply jump on the web app and get an answer right away and then move on to the next question. And that would help make this system more sustainable in the long run. And so, one of the great things about the Civic Innovation Challenge that NSF, the National Science Foundation, is running here and we're funded under is the idea that it's co creation. So, you're actually working with the community to define exactly what that should look like, what that web app should look like. And then tailoring all of the technology to basically fit that endpoint.
So we really need this model because we need to be able to predict the effectiveness of policy decisions and technology decisions that we make. And this model will allow us to test out different policies and different technologies and then have an idea of its effectiveness. And then the second reason it's important to have the model is that after we would pass the new policies or install new technologies, we'd be able to connect better with the public to show them the results and the why behind what we're doing.
Being web-based and available to everybody just really opens the door wide open for use of the model now.
I think the tool will make an excellent communication tool. In my work, I talk to utility leaders all the way down to utility operators, and I can see a way to use this model to explain how the impacts that one piece of the system would have if you make a change at one area of the system, how that could percolate through the entirety of the Occoquan Reservoir, and ultimately affect the quality of the river or the drinking water that Fairfax Water is producing for its customers.
Here, engineers, social scientists, and ecologists are working with the community to create new tools that will ensure this critical ecosystem and drinking water resource will serve the region for another 50 years.